Good morning. Let's try it again. Good morning. All right. So, Mikolai was saying in 2 to 3 years we'll be using serverless. The kind of customers that I talked to today, they are going full throttle on serverless everywhere. And it's amazing, how we have customers all across the spectrum on the range of serverless that they're doing and what really serverless is. So think about what serverless is. We generally think of serverless as a function. It fundamentally changes the way by which we build, deploy, manage, monitor our application. But is it only about functions? Or is it about containers? A lot of customers are building applications using container. And we barely got started with the containers journey, and then this serverless thing comes along. And is it enough to be in the container side of it? What about the infrastructure? What kind of things we can do in the infrastructure to make serverless that much better? So my name is Arun Gupta. Just like everybody, I have a Twitter handle as well. So I'll be talking about serverless in terms of functions, containers, and beyond. How do we see this? So let's talk about it. Let's see how the computing evolution has happened over all these years. People call us server huggers. They have their on-prem data centers. They don't want to let them go. Provisioning and building an application using those server huggers takes a while because it's a 3 to 6 months process to get a machine, install the machine, provision the machine, get the operating system, all of that. And that really slows down the amount of innovation that you can do as part of that entire process. That becomes really challenging. You have to invest heavily into the capital expenditure. And what about all the innovation that is happening in the hardware side of it? How often you can leverage that? So we saw that a few years ago, but there are still some of those server huggers around. Now, then there are people who are starting their migration to the cloud. And there are several reasons customers move to the cloud. I call them typically as A, B, C, D, E. So agility, because how quickly you can spin up the servers, you can spin down the servers, that increases your innovation factor. Then the breadth of functionality that you get on the cloud. You want a database, it's up there. You want a time series, it's up there. You want a messaging, it's up there. You want real-time analytics, you want containers, you want, what do you want? It's up in the cloud. So the breadth of functionality is huge. Cost is typically the factor by which customers start migrating to the cloud. They want to convert their capital expenditure into operational expenditure, and that's sort of their main motivation typically. The global deployment, as they say, that, hey, today my business is only regional in Ukraine, but now I want to start expanding to the rest of Europe and then rest of the world. Now, how do I deploy my applications? Can I set up my data centers across those regions? No, I can't. That's where I'm going to start relying upon the cloud provider that's going to have that different data centers and availability zones. And then last is the elasticity. You don't have to over-provision the servers in the cloud, anticipating the maximum amount of load. Intuit is a customer of ours, and they build TurboTax. In the US, the tax day is April 15th. That's about the time where their 95% of the workload is being used. But they don't have to over-provision anymore because now they know with the AWS cloud how quickly they can scale up and scale down. And so that works out very well. As I said, cost is typically the starting factor for migration to the cloud, but agility and innovation are just amazing on how much it enables you. Then the third wave comes along is of containers, where it gives you a packaging mechanism by which you can package your application, run it exactly the same way on your desktop, on your on-prem, on your private cloud, public cloud, pick your favorite cloud, and it gives you the same mechanism, the same developer tool chain you can leverage across multiple compute environments. And that works very well because it's give you one packaging mechanism, but you are still responsible for maintaining your cluster. The primitive that you are still thinking is still in terms of, I want to scale my containers, but I need to scale my cluster before that first. Okay? So there's a lot of still undifferentiated heavy lifting, as we say, that needs to happen. And then there is serverless, where you don't have to worry about any of that. You just focus on your application. You write your application code, and then you say, go deploy it. You get one dial that here is a CPU, here is a memory that I want to allocate, and go allocate other resources accordingly, and that's it. I don't have to worry about what is my infrastructure looking like, is my application highly available, because you get all of that by default. And as you see up there, we have AWS Lambda, which we started over 4 years ago, extremely popular. And we'll talk about that a little bit. And then there are services from other cloud vendors as well. Now, what does serverless really mean if you think about it? So there are 4 core tenets of serverless that we think about it. Okay, the first one is you don't have to provision the infrastructure. There is no downloading, installing, none of that needs to happen in order to run your application. You just provision it. There is no management of the infrastructure that needs to be done. You can do that same capability using EC2 as well, but then you are responsible for managing your own server. So it's really the main difference here is, there is no provisioning, no management on your side of it. It's all done by the cloud provider. Then the second one is automatic scaling. As we talked about it with containers, your unit of scalability is really not container, it's really the cluster. I want to scale my containers. I want to spin up 20 different instances of the container. There are primitives, but it's still in order to scale your container, you need to scale your cluster first. But in this case, automatic scaling, you just get one dial, and you rotate that dial, and based upon that, your application scales. You can scale vertically, or you can scale horizontally. If all of a sudden, from 10 requests per second, you're getting 10,000 requests per second, it has the ability to scale. The cloud vendor provides that. It gives you built-in high availability and fault tolerance. Once again, when you deploy your application on the cloud, then you would say, hey, I want to deploy in this region. At AWS, we have this concept of a region. It's typically a physical location around the world. And yesterday, we launched a brand new region in Hong Kong, quite far from here, but still a brand new region. We have 21 regions now and 65 availability zones in those regions. And the whole idea is it's a cluster of data centers around the world, and there are 25 of those. And then each region has multiple availability zones. Typically, each availability zone is 10 to 100 miles apart from each other. That gives you disaster recovery, high availability, fault tolerance, all of that. Now, if you're not doing serverless, AWS has all the primitives by which you can build a highly available application. Serverless gives you by default. You just say, take my function, deploy it, that'll make it highly available automatically. And last but not the least, from a customer point of view, you don't want to pay money if your application code is not running. All you want to do is upload the function code, let somebody run it, and pay only from the perspective when the code is running. If the code is not running, I don't want to pay money. AWS Lambda defines limits exactly on what you can upload and how much you can upload, but those are sort of the main 4 tenets. So let's look at some of the patterns that we have seen on how serverless adoption has looked like. On the bottom left, what you would see is sort of the traditional monolithic applications. Nothing wrong with them, but those are monolithic applications. So the first step that we have seen is that the customers do is they lift and shift those applications on their cloud journey to the cloud. Their lease for the data center is renewing. They don't want to renew the lease. They want to convert their operational expenditure into capital expenditure or capital into operational expenditure. And they say, we're just going to take that application as it is, run it into the VMs up in the cloud. And then they may say, now that I've moved into the cloud, now I can look at maybe container services. And these are AWS container services to build that whole container ecosystem around my applications. So maybe go into the microservices route and things like that. Okay? Or, well, one of the classic customers here is, for example, US Navy. US Navy, they lift and shift their application up in the cloud, and they saved 60% of their costs just because of simple lift and shift, because they don't have to maintain their own data center over there. Or the customers may take the route where they say, you know what, I'm going to containerize it first. I have my on-prem data center running for the next couple of years. I'm going to containerize my application first, and once I containerize it, then I will keep kind of adding more to it, and then I'm going to go up in the cloud. So all customers want to do is they want to get to the top right quadrant, because that sort of is nirvana for them. And then there are customers who just take that leapfrog. They just jump. They say, we're not going to go to the cloud, not going to go to the containers route. We just right away go to the AWS Lambda route, and we're going to get that full nirvana right away. Now, Fannie Mae is a financial services company back in the US, and this is exactly what they did. They just didn't go to the cloud containers cloud route. They just jumped straight on to AWS Lambda. And I'll discuss a lot more customer examples on how they're doing it and why they're doing it. The second pattern, this is the most prominent pattern that we have seen among our customers in terms of serverless adoption, is organic serverless adoption. So essentially what you do is you start with some internal IT job, log processing, cron jobs. Typically, you're running within IT, so there is no audit, no security, nothing, no provisioning that needs to be done. So you just build that, take that application, and you convert that into using Lambda. All you do is, it's a cron job, runs once a day, once every hour, whatever. You take that application, you throw it into a Lambda, you set up your cron job accordingly, it fires up every hour, runs the job, works very well for you. Then you start looking at, as you start doing many of those, people start noticing that, hey, these jobs are getting done much more faster, and we are not wasting resources, we are saving money actually on them. And then you start looking at, how your data streams are structured actually. So essentially what you're looking at is, how is the data transformation happening? There are two ways that data transformation can happen. First is a linear transformation. So for example, John Deere is our customer. Now, they have tractors and harvesters, 200,000 of those apparently, running all around the world. They generate data. That data comes to Kinesis, which is our real-time streaming platform. Then from there, they kick in a Lambda function, does some processing. They store it into DynamoDB or S3. Then another Lambda function kick in, and then they actually give it to the end user. So it's very linear processing. And then the second type of processing is data lake processing, where you have structured and unstructured data all sort of mixed up together, and then there are ingress and the egress points. And at those ingress and egress points is where you're running those Lambda functions to make sure the transformations are done correctly. And this is exactly where your project becomes super mission critical. That now I'm actually using my mission critical data here and running it through Lambda functions. And that's when you start getting notices, and that's when your director and your senior executive management gets involved into this and then says, what? If it is working for these functions over here, why not take an application and completely rewrite it using Lambda functions? And we have lots and lots of customers that do exactly that. And last but not the least, this is the pattern that excites me the most. As a developer, it's called as incremental refactoring. And the way this thing works is, Martin Fowler, he went to Queensland with his wife in 2004, apparently. And in the rainforest, he saw this thing called as strangler vines. These vines grow on a fig tree. They grow on the top. They slowly make their way down to the root. And then, over a period of time, these vines take over the root. And then the tree completely goes away. So the tree becomes the vines, basically. That's the way it works. So essentially, that pattern, if you think about it, is where you have one big monolith. You chip away a functionality. You say, I'm going to take that functionality, and I'm going to convert this to a Lambda function, and I'm going to introduce for them to talk using APIs. And then I'm going to take another part of the functionality and Lambda an API, and so on and so forth. So what you do is you take this one big monolith, you start breaking it apart using Lambda functions and APIs, and then eventually those Lambda functions and APIs working with each other really become your application. So that's, again, a pattern that excites me, and that's what I've seen a lot of success in my sample projects that I've played around with. So let's take a look at it, how all of this really started in terms of AWS Lambda. We launched AWS Lambda in 2014, as I said, so a little over 4 years ago now. It is an event-driven serverless code execution. So what you do is you take your function and a variety of languages, we'll talk about those. You upload them into AWS Lambda, again, using a variety of ways. And once you do it, then you can say, this API, this event happens, run that Lambda code. And you get paid, it fulfills all those 4 tenets that we talked about. Now, AWS Lambda is a foundational service. What that means is anytime we launch a region, like 21 regions so far, AWS Lambda is very much part of it. And that's the exciting part about it. So it is optimized for security, reliability, performance, all of those tools, all of those abilities that you would expect, essentially. Now it processes billions of requests every month for hundreds and thousands of customers around the world. That's the scale that we are talking about. So as a serverless application developer, how do I edit and debug my serverless application code? That's the first thing that comes to my mind, right? I mean, this is a developer audience, so we want to talk about how do I build that application here, okay? So we believe community is an incredible driver of innovation. We have this thing called as CloudFormation, which is basically how you create your AWS resources in a declarative language. But sometimes it could be a little bit complex. So what we did is we built this DSL on top of CloudFormation called as Serverless Application Model. Now, using that Serverless Application Model, it provides a simple syntax and for expressing the resources that you would need. So for example, I can define my function, I can define my APIs, I can define the tables that I want. If you think about it, 80 to 90% of your use cases may be covered with that itself. That's what you need mostly. I'll talk about layers. That's a new concept that we introduced at last year reInvent, and the whole concept of a serverless application. And I'll talk about that a little bit later as well. Now, it is purely built in the open source. The specification is out in the open source. The translator that takes serverless application model and converts it into CloudFormation is all out in the open source. So highly encourage you to take a look at it and contribute. Give us feedback, file bugs, send pull requests. We would love to see all of that. Now, how do you really, so understood the SAM part of it, but where developers build and code their application is something very near and dear to their heart. I don't want to go into the VI versus Emacs kind of a battle or Eclipse IntelliJ kind of battle, but we serve it all. A couple of years ago, we launched this thing called as AWS Cloud9, which is a fully collaborative managed editor running in the AWS cloud. So you can go into the cloud, provision a Cloud9 instance, build it. There's no download required. Everything is running up in the cloud. You can edit your code in there. You can provision it there. From there itself, provision it to AWS Lambda. All those things, all those tools are available to you over there. But as I said, what developers like is the tools that they use. So that's where we introduce these AWS toolkits for PyCharm, IntelliJ, and Visual Studio Code. And I typically use IntelliJ and NetBeans. Those are my 2 primary IDEs. So this is super exciting for me, because now it allows me to create my application in the language of my choice and do the full edit, debug, all that experience using the IntelliJ way, but now in a serverless world here. So that's very important to me. And the cool thing about these is these are all built out in the open source. These toolkits are out in the open source. So if there are any features that you would like to contribute, the roadmap, the whole thing is out in the open source. So take a look at this. What would you like us to do with these toolkits? Okay. So let me show you, how do you author and debug applications. How many of you are Java developers? I would expect that, right? This is jeeconf, of course. So let me show you. I have IntelliJ here. So let's bring it out over here. Okay. Now, what I'm going to do is I'm going to go say File, New Project. And in this IntelliJ IDEA, I have AWS Toolkit installed. So it gives me this AWS and AWS serverless application. Now remember, this is an AWS toolkit. So to begin with, I'm only able to create a serverless application. But the whole idea over here is the other different parts of AWS services will be integrated here as well. The first step is really the serverless aspect. So I go, OK, I want to create this. And I'm going to call this as jeeconf. I'm using Java 8. This is my SAM template that I talked about earlier. And in this case, I'm using Amazon Corretto. And I'm going to use whatever JDK, but Amazon Corretto is a JDK is a downstream distribution of OpenJDK that we announced last year. That's what I'm using here. And then it has some more settings over here. And then I can say, click and finish. And I'm going to open this in the same window. So literally with one click, specifying my name, putting all the settings, my simple serverless application is created for me. Now let's take a look at that. So this is jeeconf. This is my Maven project created inside that. If I look at my app, this is all my application code. So the idea is it gives you the application code, it gives you a request handler that you need for writing a simple serverless or a Lambda application here, okay? So now what I'm going to do is I'm going to go to the Maven panel here, and I'm going to say, add this project. So go to my workspaces, jeeconf, pick the POM XML, and add that Maven project. So I add that Maven project here. As soon as I add a Maven project, a Lambda icon appears over here. It starts recognizing, oh, this is a Lambda function. So now what I can do is I can minimize this guy here. By the way, one thing that I didn't show you here is in AWS Explorer, in settings, because I have AWS CLI pre-configured on my machine, it picked up all the connection settings for me, including my profiles and all that, okay? So all that, it automatically picks it up. So now what I can do is I can click on this Lambda function, and I can say, run the Lambda function locally. Now you said Lambda is running in the cloud, but now I can run the Lambda function locally. And how this works is we have a Lambda runtime Docker image that is downloaded on your machine, so you need Docker for this. So it downloads the Lambda CI runtime Docker image, and then mimics the Lambda runtime on your local machine. So if I say here, run local app, I know it doesn't take any input, so I'm just going to give a blank input for here, and I'll say run. Now, I know you can't see the output here, but essentially what it's doing is it's building the application, it's running the application, and pretty soon it's going to pop the window for me that, hey, this is what the output looks like. So now it says found credentials, invoking hello world app, and it runs the function, and it returns a message. It just says simple hello world message here. So that's pretty cool, okay? Now, if I want to run it, now let's refresh my Lambda functions here. And if you look at Lambda here, these are all the Lambda functions that are already deployed in my AWS environment. I can say, I can debug the local application, or I can create a new Lambda function right from here itself. So now I can say, create a new Lambda function. Okay. I can choose, what is the timeout here. So pick whatever number here. This is Java, so I'm going to pick like about a gig of memory here. Don't blame me for that. Pick up my Lambda basic execution role here. Now, remember, I'm building a single function here. But if I'm building multiple functions, and my application is microservices driven, which is very likely then I can enable something called as X-ray here. And once I enable X-ray, what it gives me is distributed tracing across all of those Lambda functions by default. I get very nice graphs. I see bottlenecks. I see performance heat maps on what's going wrong, where, what is taking more time, that kind of cool stuff. So we won't dig into that. And then I specify S3 bucket, because now what IntelliJ is going to do is it's going to package up my code, upload to the S3 bucket, and then it's going to take that zip file and it's going to deploy it to the Lambda function for me. But all of this is completely abstracted for you. So once I say create function, so all the magic is now happening behind the scene for you. But for me as a developer, I want to understand what's really going on, what pieces are going where. I don't like black magic. I want to always see under the hood here. So now it says Lambda function jeeconf created. So let's refresh it here. And here you go. So I got my jeeconf function here. Okay, now if I want to, I can run this remote function, and very cool. Okay, so we won't dig into that. It's going to give me the same response anyway. Now, the other part that I want to quickly highlight here is I have the template.yaml here. And this template.yaml is really my serverless application model. And in this case, you can see on line number 13 is where I'm showing what my resources are. Then I can say this is my function name. Here are my properties. I'm using Java 8, defining different params. This is the API where the function is exposed. Now, this is a very standard CloudFormation code, as a matter of fact. So if you are using other AWS resources, you can embed them into here. So that kind of makes it very easy. One of the new functions that we introduced last year was Lambda Layers. This was introduced at reInvent 2018. Now, it lets you take all the shared code that you have and essentially introduce it as a new layer. It has all the IAM capabilities, the security that you expect, that who can access that Lambda layer, all the capabilities that you would expect typically. So for example, in this case, I have function 1, 2, 3, and 4. They have their own business logic, which is, of course, unique to them, but they're all using lib A and lib B. There's a lot of code repetition that is going into as part of my Lambda function, even though you're not charged for it, but that's still a maintenance nightmare from your perspective. So what you can do is, in that case, you can grab those lib A and lib B, combine them together, put them as a Lambda layer, and have all of your Lambda functions really rely upon those Lambda layers. So this is really, don't repeat yourself, the dry principle that is being cried into action. And the access to these Lambda layers can be fully controlled using IAM policies. Now, let's take a look at how or what is the specific example on how we are using that within Lambda itself. Now, in Lambda, we have, of course, support for a whole bunch of languages. So Node, Python, Java, Ruby, .NET, Go, PowerShell, all of that. Okay? Using that same concept of Lambda layer, we also added support for C++ and Rust. So basically now, C++ and Rust are just one more layer, and you can write your functions on top of that, which you all have access to, and you can write your functions in Rust. So that's pretty cool. And then, of course, we have a whole lot of partner-supported languages. I mean, who knew PHP and COBOL are still pretty hip, that we're going to write Lambda functions in them. I've seen Fortran, I've seen Erlang, all sorts of Lambda functions, people have created just to play fun of it. And I think the key part really here is, because the C++ and the Rust runtimes are open source, you can take a look at this, how they are implemented. And that kind of maybe will motivate you to write a runtime of your own choice. Now, I do have lots of these Lambda functions. I have not just Lambda functions, but other services that are collaborating with it as well. What does my application look like? And that's exactly where you take a look at step functions, essentially. So what it gives you is the ability by which you can easily orchestrate between these functions, create like a state diagram, and it can track state between, if step A succeeds, then do this. If step A fails, then do this. It gives you a full state machine, essentially. Now, many applications contain workflows that must execute in a reliable manner and repeatable sequence. And a lot of customers have been asking us that just Lambda is not enough for us. Give us an integration with a lot more services as well. So in that step function, you can integrate a whole lot of services. So whether it's SNS, SQS, AI machine learning, a lot of customers are heavily using Lambda functions over there, or containers, any of that. Okay? So all of those services can be very easily integrated using those workflows that I talked about in the step functions. Now, we talked about functions. That is sort of the primary use case that most of the customers typically understand. How can we apply those benefits to other services that are running in AWS? So we introduced last year the GA of Amazon Aurora Serverless. Amazon Aurora is a database service from Amazon. It's the fastest growing database, fastest growing service at Amazon. And applying serverless concepts, this particular service is very useful for burstable workloads, where I need to query the database, or I need to store something into the database only for like maybe once an hour, or I do this like once in a while. So in this case, all you do is refer to a database endpoint. The database, of course, the data is persisted into the database. And on demand, the database will start up, serve your needs, and shuts down. And you really pay per second over there in terms of how the utilization is. Okay, so I think that's the same serverless tenets really applied to the database side of the land as well. What about containers? So we talked about it, that, yeah, serverless is good. The tenets are nice and cool. I'm really excited about it now. But if you think about serverless, there are two distinct values of serverless. There's a build tool, and then there's a deployment vehicle. It really allows us to build and scale modern applications. Now, under the hood, if you look at it, you got lots of EC2 instances running, which is your data plane. And then on the top, what you have is a control plane. Control plane, you need a cluster manager because you got lots of EC2 instances running. Somebody got to manage that. And then there's a scheduler, which will say which container to be scheduled where. And then there's a controller, which will say, oh, you want 5 instances of this service. I'll make sure that that's keep running. So you need control plane and data plane in order to run your containers. Now, whether it's ECS, whether it's Kubernetes, you pick your favorite orchestrator, they both have this concept. Now, just like Lambda made it possible for you to not do any undifferentiated heavy lifting, we introduced this service called as AWS Fargate, and this was about 2 reinvents back. And essentially, what it says is you don't need to manage a control plane or a data plane. You want to run a container, you give us a container, and we will run the container for you. And just a year after general availability, this was made generally available in reInvent 2017, AWS Fargate run tens of millions of containers every week for our customers. So it's extremely popular. Samsung actually built their developer portal using Fargate and reduced their computing cost by 50%. So again, the concepts of serverless really applied to Fargate. So how does it work? You build a container, and of course, you build your Docker image. That's your basic Docker image. And then you say, there are 40+ combinations that are available to you. How much CPU do you want? How much memory do you want? And with that, accordingly, you are allocated network and other aspects of your applications. So this is the model that we were talking about. Yeah, of course, we have ECS, which is Elastic Compute Service, or ECS for Kubernetes, or EKS rather, Elastic Compute Service for Kubernetes, which is a managed Kubernetes service for us. So that's where the control plane is. But now you have this layer called as Fargate. Instead of managing your data plane, you can just give the container to us, and then we will manage it for you. And we will, again, scale it, manage it, provision it, all of this for you. You don't have to worry about creating a data plane at all for you. So just like, and if you think about, there's very much the same analogy in that sense. There is a data plane for you, which is where your Lambda functions are running. And the way you interact with the control plane is using the AWS CLI or AWS console or IntelliJ IDEA, whatever your favorite tool is. And that's how you interact with the control plane. Now we look at it in terms of, if you look at the compute services across Amazon, we have a shared responsibility model. You can do everything that I explained. You can definitely do this with EC2, but you eventually end up doing a lot of handwork by yourself. But as you move up, you can do this with container services or Fargate, or you can go full-blown Lambda functions. That, you know what, I don't want to care about it. I only want to focus on the application code. Let me build that and let somebody else manage that for me. So I think this is a really good way by which you can define what is the ownership for me and what is the responsibility for me and how much I'm willing to take shot at. If you look at the serverless landscape at CNCF, even though AWS Lambda is the one that started it, but over a period of time, if you realize there are tools, framework, platforms, and a wide range of capabilities that are available over here. Now, if you think about AWS Lambda kind of becomes the glue between different AWS services. So for example, I can say, if an object is stored in Amazon S3, trigger a Lambda function. If I receive an event in SNS, trigger a Lambda function. If I somebody calls the API, trigger a Lambda function. So it works very well that way. But that's all within AWS. And there are similar services for other cloud providers as well. But what if I want to trigger a Lambda function when my object is stored in another cloud provider storage? Or if something is stored in S3, I want to trigger a Lambda function, corresponding Lambda function in a different cloud provider. Well, that's where Cloud Events specification comes in very handy. Cloud Events is a specification that is created by the CNCF Serverless Working Group. And they are defining how these events can go across multiple clouds. As you can see, the version is very early, so 0.2, but definitely worth a look, by which you can take a look at on what they're trying to achieve over here. So I would say, again, CNCF, so definitely participate early. Now, serverless makes you it requires you to make investments, all the layers in your stack. But what about infrastructure? We looked at sort of our function layer. We looked at sort of our containers layer. But what about infrastructure? What can we do over there? Now, if you think about containers, there is no concept as containers. It's basically nothing but C groups and namespaces, all those put together that becomes a container, essentially. And containers are not meant to run in a hostile environment. By that, I mean is, if you're giving me a container, I can't run the containers from two different banks, as a matter of fact, on the same piece of hardware. So there's a bit of an optimization. There's a bit of a security that we need to do. So what we do is we take a VM or an EC2 instance as a hardware boundary, as a virtualization boundary, so that we can give you that level of security. Well, this leads to inefficiencies for us, because we can't really leverage all the innovation that we're doing within the AWS compute layer. And that's what made us go back to the drawing board. Is really EC2 or the VM the boundary, security boundary that we should have? That's where we developed called as Firecracker. Now, Firecracker is an open source virtualization technology. It's basically a what it does is a VMM, or a virtual machine manager. And what it does it allows you to create what we call as a micro VM. Now, micro VM gives you the security and isolation of traditional VMs, because it's based upon a KVM, which is baked into all modern Linux operating systems. But it gives you the speed and density of containers. So we really take micro VM as sort of the boundary. And micro VM can be easily provisioned on a bare metal or using nested virtualization. So what that gives us is the ability that we can have a big bare metal machine, and on that big bare metal machine, we can have multiple micro VMs being provisioned. And the exciting part is where I got involved with the project last year, is we built this at Amazon. So what are the benefits? Essentially, as I said, Firecracker micro VMs use KVM-based virtualization. It really gives you security from the ground up. A very minimalistic device model, really just two devices, so VirtIO and Net, and VirtIO Net and VirtIO Block. Those are the only two devices, a single-digit keyboard, and that is only used for rebooting the machine. I mean, reboot is a command, but it basically terminates the machine. So really very minimal device model, so very minimalistic surface area on which you can hit on the security side of it. And because of that, it also gives you speed by design. And what that means is the micro VM can start up in less than 125 milliseconds. And you can launch about 150 micro VMs per second per host. So if you have multiple hosts, the ability by which you can fire up the micro VMs and terminate the micro VMs is pretty huge. And because it is giving you a security boundary, you can really take a Fargate instance and put it into a Firecracker. And that's the model that we are heading towards. Now, Lambda is definitely heading towards 100% being run into Firecracker. That's where we're looking at. And Fargate is also getting towards that model. So that's the program that we're actively working on. And it really gives you, because of a very low footprint, the density of this is very high. For really less than 5 megabyte memory footprint from the micro VM. So would you provision a Firecracker micro VM, like an EC2 micro VM? No, it's not. Firecracker is a much more foundational technology from a developer perspective. So Firecracker sits at the very bottom of the layer. As I said, it definitely would be used by AWS Lambda. AWS Lambda is actually moving towards using 100% on Firecracker. Now with AWS Fargate, for example, as I said earlier, the containers are host-style. So what we do is you say, give me a half vCPU and an 128 megabyte memory for Fargate. Well, we don't have a EC2 instance that big. So we take the EC2 instance that closely matches that and then put Fargate container in that. But that means the rest of it is not utilized. So that's very inefficient utilization for us. So what we are doing is with Fargate, we can have a big bare metal instances in the back, and we can provision as many micro VMs on that, and in each micro VM can be exactly tuned what is it that you need, and it'll provision that. So it's a much higher utilization. And you may ask, I'm a customer, what's the benefit to me? You are improving your utilization. Well, the benefit to you is earlier this year, Fargate reduced its prices. And we reduced the prices by almost 50%, really from 20% to 60% in a wide range of choices, depending upon what are the combinations that you're using. So because of improvements like Firecracker and Fargate running on Firecracker, you are actually getting cost reductions as well. We also work with Kata containers. This is an OpenStack project. And then they showed how you can use, so Kata containers uses QMU as a VMM, or a virtual machine manager. But if you look at QMU, it's a fully functional virtual machine manager. So one of their biggest asks was, we need a minimalistic virtual machine manager. And that's exactly where Firecracker fit in. So Kata containers, right after when we announced this at re:Invent, 2 weeks after was KubeCon in December itself. We had a really nice hackathon. And as part of their release, Kata Containers 5.5, they actually built integration of Firecracker. So you can say, take Kata containers, run it on Kubernetes. You can, by default, use QMU. Or you can say, don't use QMU, use Firecracker as a micro VM. And there are blogs that I wrote with one of the people from Kata containers. So take a look at that. And then we're also working on Firecracker and container integration. That's exactly how we're going to enable how you can run a pod, a Kubernetes pod, for example, in a Firecracker micro VM. So those are the aspects that we're looking at it. So my point being, Firecracker is a much more foundational technology. Why does this all matter? So if you think about it, from a serverless perspective, it really removes the undifferentiated heavy lifting. You don't expect, we don't expect you to download a software, or build something, or provision something, or manage something. We just want you to build your application. We just want you to be excited about building your application, where you don't have to focus on any of that. So we're going to, at Amazon, we fundamentally believe in innovating, which helps us, our customers, to innovate, essentially. And that's the reason we have been continuing to innovate it. So really, my only ask from you is really go build your application. And as Mikolai said in the very beginning, we truly believe that serverless is really changing how we're going to build applications. It is already changing for a couple of years, and it's anybody's guess at this point of time where we're going to be in a few years out. So my ask for you is, go build the application. I'm around all day. Let's talk more. Thank you.